electrical device which basically increases or decreases the voltage. And it does so by ensuring that it increases or decreases the voltage at the cost of current, because the power has to remain the same, the input and the output power. Now, do you all understand, Mozam, Janita, Aishal, Basil, Asma?
Yes, sir.
Yes, sir.
So
Yes, sir.
this is not the answer to the question, but I'm just writing the definition in order for you to recall. Transformer is an electrical device that converts the, that steps up, which means increases, okay, or steps down, which means decreases, okay, the voltage. And this side, which I'm highlighting in color red, what is this side called?
Primary coil, I think.
Sir, fine.
It is called the primary side of the coil. Well done. What
Yes.
about the other end, which I am circling in green? What is
Sir,
that?
Secondary.
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 That is called the secondary side. Well done. Brilliant. Moving ahead, now let's look at the question of this past exam. What does this question say? Can someone volunteer to read if possible, please? Asmat, Basel, Ishal, Azam. Can someone
Yes,
please read
sir.
the question?
I'll
Go
read
ahead,
it. Uh,
please.
Figure 8.2 shows a DC supply connected to the input of a transformer. When switch S is first closed, the needle of the galvanometer deflects briefly, then returns to zero. Explain why the brief deflection occurs.
Okay, so why does the deflection occur? And you have to explain for 3 grade points, which means with also the reason being there. So can you explain why the deflection is happening? When the switch S is first closed, the needle of the galvanometer deflects. Deflects means it moves here and there. Briefly means very slightly it moves and then it gets back to the zero. Why does the galvanometer needle deflect? Yes, please. Answers? Hello? Hello? This relates to the working of a transformer. Janita, Basil, Mozam, Asmad, Abdullah. Can someone, Mozam, answer this? Come on.
So basically, when the current passes through the coil,
When the alternating current is, when the, okay, this is a DC supply. It's not using
yes.
AC supply. That's a very strange thing over here now. Because transformer has to work with an alternating current and not a direct current.
So are they
When the
using
switch is closed,
secondary?
the current through the coil passes and increases, causing a change in magnetic field, which causes a change
Which
in magnetic flux through the secondary and causes the galvanometer to deflect. But because it just rises and comes stable in a very instant moment, so it returns back to its zero position because the change in current stops happening, so the change in magnetic field stops happening, and there is EMF induced then in the secondary. Does that make sense?
yes. So is it because it's a DC supply
It is
that
a
the
DC
current is
supply.
not?
If it was AC, it will be continuously changing the current. So a continuous changing deflection would be shown, Abdullah. But if it is an AC supply, just like the one that is connected, this means that it is not going to continuously change. It's going to just, when the switch is closed, rise momentarily and get constant. So during the time of the rise only, it will be changing because it will reach its maximum position. During that, it will show the deflection very briefly for a very short time and then return back to its original position. So for 3 grade points, the Cambridge wants you to also write the answer. So you will write that the change in current, okay, the change in current happens as the switch is closed before reaching the maximum stable position, direct current, okay, and during this changing current, um, the magnetic field through the secondary coil, changes causing the EMF induced EMF, causing the EMF to be induced, and galvanometer shows a brief deflection. Okay, because then ultimately it gets a maximum stable, so it no longer is going to cause a deflection. Please ask if there are any questions.
Sir, can you like explain?
I will explain again. Okay, I'm going to explain this question again. Now listen very carefully. Basically, whenever the current passes through a conductor, it creates a magnetic field. That's something
Yes.
you know, right?
Yes, sir.
So in this case, there was not an alternating current, there was a direct current, right? So when the
Yes,
switch
sir.
was closed, in a very short time, it reached the maximum and then stayed constant, right?
Yes.
So during that short brief time when it was turned on and the current was going to increase through the primary, it caused the changing magnetic field, and through the secondary the changing magnetic field caused a deflection. But as soon as it got stable, the deflection
Yes.
stopped, because for induced EMF the magnetic field must be changing through the secondary coil, which is
Yes.
no longer changing after a certain moment.
Yes, sir.
Does that make sense?